Hello, today our group will be uh, explaining approximate analysis that we conduct in the lab- laboratory. So, what is proximate analysis? Proximate analysis is a basic laboratory method used to determine the main nutritional components of food, like protein, fat, carbohydrate, and fiber. It shows that it measures moisture, ash, like minerals, protein, fat, fiber, and carbohydrate. These values help to understand the food nutritional quality, energy content, and shelf stability. Each component is determined through specific chemical or physical tests to give a complete overview of the food composition. Like moisture, it measures the amount of water in the food. It affects freshness, texture, and shelf life of the food. So ash, it shows the total mineral content like calcium, iron, and potassium. It's what left after burning the sample because mineral can't be burned. So protein, it indicates the amount of protein which help build and repair body tissues. So fat, it measures the oil or lipid content that provides energy and help absorb vitamins. Fiber, the part of food that the body can't fully digest, helps in digestion and maintaining bowel health. Carbohydrate calculated by difference provided the main source of energy for the body.
So, what is the objective of proximate analysis? The objective of the proximate analysis is to determine the main nutritional component of a food sample, including moisture, ash, protein, fat, fiber, and carbohydrate. These help us understand the food nutritional value, quality, and how suitable it is for consumption or other processing. This also tells us on how to nutritious the food is, its quality, and whether it is good to eat or use in other products. So, moving on to methodologies. In our proximate analysis, we check the main nutrient in food sample. In our food sample, moisture was measured with an oven to see how much water it contains, while mineral or ash were measured with a muffled furnace. Protein was determined using the Kjeldahl method, and fat with Soxhlet extraction. Fiber was tested by acid and alkali digestion. Carbohydrate were calculated by differences, and energy was estimated using the add-water factor. Knowing this nutrient help us understand the food nutritional value and quality. For example, moisture affects shelf life. Minerals are essential for health. Protein and fat provide energy and structure. Fiber and aids digestion. And carbohydrate supply fuel for our body. Using proximate analysis is quick and effective for evaluating food, guiding product formulation, and ensuring it meets nutritional standards. The data can also help us compare food, plan diets, or design new products. Altogether, this method gives a complete picture of what is inside of our food sample.
So the result that we get after we doing the approximate analysis is moisture we got 0.92%, ash 1.87, protein 9.49, fat 27.54, and carbohydrate 60.1. So the total is 100%. So according to the result that we get, we can compare the nutritional labeling that appear in the package. So protein 9.49 and protein 8.4% maybe have a slightly different uh, a different content on the biscuit that we conduct the proximate analysis. It doesn't uh, So, nutrient from ash experiment. This biscuit sample recorded ash value of 1.5%, 2.10, and 2.0 with an average ash content of 1.87. So this value represents the total mineral or inorganic matter remaining in the biscuit after combustion. A relatively moderate ash content indicates that the biscuit contains an adequate amount of mineral mainly derived from ingredients such as wheat, flour, salt, and other additives. Small difference between replicate may be due to slight like weighing error or uneven burning during the analysis. Yeah, like we use the machine in well, laboratory, so it different with the industry equipment, right? So ash content serves as an important indicator of the product's mineral composition and the quality of its raw material. Overall, the results suggest that the biscuit has an acceptable level of mineral and that the analysis was carried out accurately under controlled conditions. So, the biscuit sample contained 0.92% moisture, indicating a very low water content. Such low moisture is desirable because it helps prolong the shelf life of the biscuit and reduce the risk of microbial spoilage because microorganism needs the water to reproduce. Right. So during baking, most of the water evaporates due to the high temperature applied. So moisture level can be influenced by factors like baking duration, oven temperature, and the type of ingredient that we use for making the biscuit. This result suggests that the biscuit was well baked and sufficiently dry, ensuring good texture, quality, and storage stability.
From the fat experiments, the fat analysis results show that the biscuit samples had fat contents of 31.11%, 35.01%, and 16.51%, with an average value of 27.55%. This indicates that the biscuit contains a moderate amount of fat, which plays an important role in providing energy and improving the texture and flavor. The difference in fat content among samples may be due to variations in sample composition, incomplete fat extraction, or minor handling error, such as solvent residue or sample loss. The noticeably lower value in third sample could be caused by inconsistency in sample preparation or measurement accuracy. Overall, the result shows that the biscuit has a fair fat content, contributing to its palatability and energy value. So, for the nutrient from protein experiment, the biscuit sample recorded protein values of 9.96% and 9.01%, with an average protein content of 9.49%. This result indicates a moderate level of protein, mainly coming from the ingredients such as wheat, flour, and milk powder. Minor differences between replicates may be due to slight variation in sample uniformity or measurement accuracy during the analysis. Protein plays an important role in contributing to the biscuit's structure, texture, and overall nutritional value. Overall, the results suggest that the biscuit contained an adequate amount of protein that the analysis was carried out carefully under controlled laboratory conditions. So, for the nutrient from carbohydrate experiment, the biscuit sample contained 60.18% carbohydrates, indicating that it is good source of energy. Carbohydrates are mainly derived from ingredients such as wheat, flour, and sugar used in the biscuit formulation. During the baking process, starch in the flour gelatinizes and later hardens, giving the biscuit its crisp and firm texture. The high carbohydrate content also enhances the biscuit's sweetness and overall palatability. These results suggest that the biscuit provides an excellent source of energy and possesses good quality and taste, making it appealing to consumers.
The challenge and error that we can get from the proximate analysis is firstly instrument calibration, like inaccurate or uncalibrated equipment. For instance, ovens, balance, or furnaces that can lead to incorrect reading and affect the reliability of the results. Then we have the sample homogeneity, which is uneven mixing or grinding of the sample can cause inconsistent measurement, especially in moisture, protein, or fat analysis. Moving on, we have the environmental condition, which is the factor such as room humidity, temperature, and air circulation that can influence drying and weighing process, especially for moisture dissemination. Then we have the human error, which is the mistake that will be done during the weighing, transferring, or timing that can result in deviation from the actual values. Last but not least, we have the reagent quality, which is using the expired or impure chemical that can affect reactions, particularly in methods like Kajaldal or short slab extraction. Last but not least, we have the impact of proximate analysis. Proximate analysis is not just for the lab, it has many real world applications. The data help create accurate nutrition label on food packaging so consumer knows what they are eating. It also aids in setting product price based on nutritional quality and ensures regulatory compliance with national and international food safety standards. Consumer benefits too, as this information help them make healthier choices. Finally, the data is valuable for research and comparison, allowing us to compare the different brand or formulation and improve food products.
So, in conclusion, proximate analysis is an essential method used to determine the basic nutritional composition of food, including moisture, ash, protein, fat, fiber, and carbohydrate. This analysis provides valuable information about the food's quality, nutritional value, and suitability for consumption. It helps manufacturers maintain consistent product standard, improve the formulation, and ensure food safety and labeling accuracy. Overall, proximate analysis plays a key role in food science, which is very important, and industry by supporting the quality control, product development, and consumer awareness.